Okay, welcome everybody back after hopefully a restful holiday. So we're going to get cracking straight into statistics. I'll just talk about our new notebook here. This breaks it up into two tests. So the first test is on chapter 7, just chapter 7. And then the second test, which will be later in term 3, is on chapter 8 and 9 on continuous random variables. So we're breaking it up like that. Chapter 6 was sort of holiday homework. I sent you the list about halfway through the holidays. If you didn't do it, I encourage you to. If you got stuck on 6C with manual standard deviation calculations, I've sent through a video on how to do that. I encourage you to look at that. But it will pop up as we progress through this unit and into the next unit. So just our plan for this term, we will do chapter 7. And so we're sort of breaking up calculus, right? Because we do differential calculus in term 1, and then we're going to do statistics now, a unit of statistics, and then we're going to go back to some calculus techniques where we start looking at integration, right? And I've got two reasons why we do that. The first reason is that's how I've done it for a long time, so we just keep on with the trend. But I think the second reason, maybe why we set the course up like that, is because it allows retention. And what I mean by that is we've done calculus and we're going to sort of not do it for the next 4 weeks, and it's going to be 6 weeks when we account for holidays, and then we have to recollect all of that knowledge. And so that's going to help us when it comes later in the year because we've had an opportunity to retain some of that information. The same with statistics, we're getting exposure to it early, such that when we move on to it again in term 3, we've witnessed some of the concepts and we're ready to tackle some of the later stuff. Okay, so that's our plan for this term. We'll start with chapter 7. We should have 3 tests this term. Chapter 7 is a short unit, it's about 3 or 4 weeks. Then we'll have integration, 2 tests in integration, which we should get done before the end of term as well. We'll also start our folio task before the end of term. That's our plan for this term. As far as your applications of calculus tests go, well done. It is a tricky test, isn't it? And we'll hand those back soon. Not today. I need to catch up with Mr. Virgo, see how his classes are going, make sure they're all done. I'll scan them and then we'll make sure we get them back to you. Opportunity to catch up, go through anything you want to ask about. Let's get straight into what we're talking about today. So if we turn the page to 7A, all right, so we're starting with chapter 7. My plan today specifically would be to do 7A and 7B. So we have random variables here. And the thing with statistics, it's a bit different from calculus. It's not like you get a rule and let's apply the rule over and over and over again. We're going to get lots of information that we need to comprehend. So we'll read through some of it. 7A is just about random variables, and you can think of a random variable as just something that arises from a statistical analysis. So we've got here, a random variable uses numbers to describe possible outcomes from some random experiment. Random variables are either discrete or continuous. So we've got that distinction. Discrete things that you count, okay? Discrete random variables take on whole integer values. These are things that you count. How many goals in a game of soccer? How many cows are there in the field? Okay? Whole integer values. Whereas continuous random variables exist on an interval. These are things that you measure. So how tall are your 12s? How long does it take to run 100 meters, etc. Things that you would measure. So let's get straight into our example problems. State whether the following are discrete or continuous random variables. So if we have the number of players on a soccer team, it's something that you count. So question 1A, that's going to be a discrete, takes on whole integer values. We'll go through them pretty quickly. I think just write a D or a C, discrete, D for discrete, C for continuous. B, the distance from school to a student's house, that's something you measure, that's going to be continuous. The number of pencils in a pencil case. This is going to be discrete. It's going to take on a whole integer value. It's something that you count. Number of cars in the car park, also something you count. So that's discrete for D. E, the time taken to drive home from school, something you measure. The width of a TV, something you measure. So E and F are both continuous. And then G, the amount of pages in a book is discrete, something you count. Very good. Okay, a dice is rolled to... So now that And what we're doing in chapter 7a really is we're pointing out the distinction between discrete and continuous, and then following that, all of chapter 7 is about discrete variables. Okay. A dice is rolled to produce a variable x. Explain why x is a discrete random variable. So if we look at the why is it discrete? Okay. The possible outcomes when rolling a dice are all integer values. Therefore, x is a discrete variable. All right. The possible outcomes when rolling a dice . So when you roll the dice, you're not going to get, 6.35472. You get a whole integer value, don't you? And then part B, state the possible values of x. Well, x could be 1, 2, 3, 4, 5, or 6. So yeah, that is how easy this exercise begins. Okay, we've got number 3. The length of a student's hair is measured. Is this a discrete or continuous variable? We're measuring, so it's continuous. And then B, state some possible values for x. So, you could be bald like me, or you might have hair. Who's got the longest hair in class, do you reckon? Raj? How long's your hair, do you reckon, Stella, if we measure 50 centimetres? 30? We'll just put let's just say a 50 for someone that's got really long hair. And so what we're saying is within that interval, okay, look at the distinction between the two. This is an interval, these are whole integer values. Very good. Let's stop there, rip into exercise 7a. I reckon on the checklist,